Right. Good evening, everybody. I believe you can hear me loud and clear.
Yes, we can hear you.
Okay. All right. We are again back to class, and I hope all of you are doing well.
Yes, we are.
That's right. That's right. Okay. So how is life treating you? Are things going well with you, or there are still some challenges to overcome?
Prof,
Yes.
as for challenges, they are with us,
Okay.
and we are managing them.
Okay, that's right. Well, that's right.
Because without challenges, we cannot. I'm not sure that even those who are in the government, they have more challenges than us.
Okay. Okay.
The high position for the high challenges, we are with them. They are with us. So we are moving together.
Can you view the slide I'm sharing with you? Hello, can you hear
No,
me?
yes, but I cannot see it from my side. I don't know about the others.
It's not visible.
It's not
It's
visible.
not, we can't see anything.
Okay, all right then. Erasmus, how are you?
Prof, I'm fine. Oh. What about you too?
I did like I know the for the past
God is
few days. Since for the past few days, I've not been feeling too well. You know, in Africa, when we are sick, it's basically going to be malaria.
mm-hmm.
So I have to struggle with malaria, but I'm fine this evening.
We
Even
thank God.
for that reason, I wasn't able to meet the Saturday group on Saturday,
Yes.
so they are lacking behind.
I saw the message that day that you were not going to be available.
I wasn't feeling well at all. You know,
So
you
sorry.
take take this Western medicine. The Western medicine couldn't work well, so I have to switch to traditional medicine. You know, when we were young, we lived in the village, so we know the traditional medicine. So I have to apply some of those traditional medicine we used to take when we were young, and it has worked. It has rather worked. Anyway, okay, so let me. Uh,
The dosage, you don't know exactly which dosage you're supposed to use. So
that's the
for
problem
that
with the
we have.
traditional one. Oh, we don't know the dosage, so sometimes it rather tends to hurt us because we don't know the dosage, but we still manage it anyway somehow. But it's not the best. The dosage is the problem because sometimes they will tell you that take two cups. Somebody will tell you take only one cup, and then we also don't know the concentration. Hmm. The traditional medicine is not bad, but we need to scientifically treat it with dosage, appropriate concentration, and so on. When you go to hospital in China, you will not see Western medicine. Everything is traditional medicine. So when we were there, we were sick, we went to hospital, they'll give you leaves, then some kind of trees, leaves, and so on. They will say, put it inside hot water. So that was what they were giving us, and it worked. But they gave us dosage. It should be 1 cup of hot water, drop this quantity inside. Then we'll only be drinking it, and it worked. But yeah, anyway. All right. Now, by the way, so let's begin today's class. I'm sure you can see the slide I'm sharing with you now.
Yes, we can see now. It's better now.
It's better. I will make it even better still. You know, last week when we met, we talked a lot about parallel databases and distributed databases. And I told you when we meet today, we will be moving to data warehousing. Data warehousing, in fact, will be a course on its own that will be treated throughout the whole semester. But in our case, it's integrated into advanced databases. And therefore, we would not be able to treat every aspect of it, but at least I would try and treat it up to data warehouse design, so that at least we will understand how to design a data warehousing systems. And some of you may encounter data warehousing along your career path, and you can use the concept that you will be learning from here to carry out the design. We may also talk a little bit about database, how the engines, the analysis, and maybe few of the queries and so forth. I think that we can finish discussions on data warehousing within 2 meetings. So today and another meeting, we should be able to finish with that. Now, it will be good to now discuss the concepts. You recall that when we started looking at the database management systems, we started from the beginning, and we talked about the flat file system that couldn't meet our needs because it wasn't able to give us ability to share data and many more other challenges that it was confronted with. That led to the development of databases or database management systems that enable us to share data. Now, it has come to light that even with the database management systems, there are still certain challenges, particularly when we come face to face with big data and different types of data presenting itself in several structures and so forth. There was then the need to see how data could be analyzed better than depending only on operational databases. Operational databases in this context is about the relational or database management systems that we know. The database management system that we know, we can represent data in, if you are using relational databases, rows and columns. And the data needs to go through certain kind of design. You will need to ensure that you have entities, attributes, and you need to structure the data. It's heavily structured before you can save the records into tables and so forth. But then the argument came up when we realized that when it comes to certain decision making, these database management systems, as it were, wasn't able to provide us or answer certain questions when it comes to management or top management decision making. Because decision making is not only based on data in operational systems. So much data cannot be represented or stored in a relational database. So in an organization, it has been found out that only 35% of all data generated by the organization can be represented in database management systems. That is maybe rows and columns, structured and so forth. Then what about other 65% of data generated in our organization? Or where do we store them? How do we analyze them? Do we mean that that data or data in different other formats could not be analyzed to give us some kind of decisions? So these days, so much data is generated, and such data, so to speak, is unstructured. For instance, if we generate a lot of data through company minutes, maybe minutes of meetings where decisions are taken, where do we normally store them? Let me ask you, the minutes that are generated from departmental meetings and so, where do we store them? Anybody? Can somebody help me? Where do we store them? What is this? Isaac.
Prof, most of the times they are stored on the secretary standalone system where he would organize them and then send them through emails to everyone. But there is no place on a database that normally we store corporate minutes like that.
Okay, that's good. That's very good. So now the emails that are generated, official emails that are sent to stakeholders, and stakeholders respond to it, and I mean, we take decisions based on what the stakeholders are saying or suggestions that we make in those emails that we generate on daily basis. Every individual working in our organization may send some emails that will have to do with the business. Well, how do we analyze them? Those email data. Anybody? Let's say we want to collect all the emails that have been sent and received by the organization. Anything that has to do with the business, all the emails, they can be very bulky. Let's say we have 100 staff in that organization. Each person sends some email that has to do with the business. We put them all together, and it becomes large unstructured data. How do we analyze them to find some patterns or trends or decisions and so on from them? How do we do that? Anybody? Okay, Erasmus.
See, Prof, usually some of the company have the email server separate from, this is a big company, they had the email server separate from those work that they are doing. So to manage them very well, they just go to the email server to retrieve them for their for the use the use that they wanted to use for.
Okay. So you need to retrieve, maybe you need to search. Please, Wilberforce, put off your mic. Wilberforce. Okay, so you will see that analyzing such data becomes extremely difficult. For instance, if we have minutes of meetings for the past 5 years, and then we want to see the trend of decisions that have been made or taken over the past 5 years, how do can we have to be retrieving them one by one from some folder and be reading through, and how do we do that? So it becomes quite difficult. And another difficulty is the email data, minutes, and then many other unstructured data. They are very difficult to represent in rows and columns in the original conventional databases. If it were in a conventional database, as we know, relational database, we can easily issue a query and then find something. But these are now unstructured data. So over time, when data begins to grow, and these days the unstructured data grows faster than the operational data in databases. Look at even you yourself, the amount of unstructured data that you generate every day, the WhatsApp messages that you send, pictures that you capture and you transmit, emails that you deal with, lesson notes that you keep in folders, and all these things. How do we represent them that we can be able to find certain trends? Even the lectures that I have been making here that have been recorded, assuming that we want to put together all the audio files, and then maybe we want to put some analytical tool on it to see areas where Prof has been putting emphasis, so that the tool, maybe some machine learning tool, could read through that large volume of lectures I have given, and then summarize it and give a certain sort of decision or certain trend that has come out, or patterns that has come out from all my lectures. How do you do that? Which database do you store them in? So over time, it has been seen that operational systems have not been able to address all our needs. As I told you, research has found that it only saves us to 35% of organizational data. To make a decision, we will need to now depend on both structured and unstructured data for top managers. Otherwise, if they only take decisions based on the operational systems, then there could be a problem, because there are so much also unstructured data. Okay, having given this background, we will soon now go and then define what data warehousing is all about. So I'll take you right to the definition of data warehousing. Then I will explain further certain keywords that we need to know. I hope you can see the definition on your screen. So what is the definition of a data warehouse or data warehousing? A data warehousing is a subject-oriented. Please take note of that, subject-oriented, integrated, non-volatile, time variant. These are the 4 key properties of a data warehousing. Once we know this and what they mean, all other things are easier to understand. So it's a subject-oriented, integrated, non-volatile, time-variant collection of data in favor of what? Decision making. So that is it. By this time, all of you should at least be making attempts to mention these 5 words right from your head. Subject-oriented, integrated, non-volatile, time-variant in favor of decision making. Maybe one student should try it off head. One student should tell me, mention all of them off head. Who is going to try?
Fortune.
Fortune. Okay,
Yeah.
Fortune, go ahead.
Subject-oriented, integrated, non-volatile, time-variant collection, and then decision-making.
You are right, Fortune, you are right. You are right, thank you. So now that you have mentioned them, we are coming to explain what they mean. Once we understand the meaning, all the other things that we'll be doing under this chapter will all be based on one or all of these. Nothing will differ as we go along. They will all be based on this. Okay, so let's start from subject-oriented. In fact, if you don't understand subject-oriented, you can't do that data warehousing design. You can't simply do it if you don't understand subject-oriented. So we'll take the subject-oriented first. You know, so far, when you've been treating database management systems, you will see that the whole database management system is based on a discipline or an application area or a business process. So even look at the practical work that I gave you. You see that, let's say we want to do payroll, which is an application area or a business process. Stock management, business process. A student records management, business process for schools. Accounting software, business. Auditing, they are all organized based on the business process or what we call applications. Now, when we come to, okay, let's still concentrate on that. The problem with organizing data based on business processes in a particular organization, there are, let's take University of Ghana, for instance. The University of Ghana has several business processes. One of them is the student records. Another one is the staff records. They are all organized based on business processes. Which other business applications do you think we have at the University of Ghana? Anybody? I mentioned staff records, student records. Which other ones do you think we have?
Financial record.
Financial record, maybe payroll, asset management. Any other that somebody can mention?
We have the library system.
Library system, hostel management. They are all organized based on particular business process or an application. So let's say we take asset management. In asset management, you will see that there are, in fact, for each of the business processes, the idea is to really make profit or whatever. So when it comes to, let's say, students' financial system, the idea may be that we want to make some profit or we want to improve some performance or whatever. There are certain things that cut across, or certain subjects or key issues or success factors that cut across all the various business processes. For instance, when we take hostel management, I believe one of the things that might be of interest to the university is how much profit or money have we made from the application, the use of that application. So profit may be one of the things that may be or losses or profit might be one of the things that will be of interest. That's hostel management. When you come to, let's say, students' fee payment management system, of course, profit or revenue, maybe let's make it revenue, maybe one of the key issues over there as well. Even so, when you begin to look at various business processes, there will be something we call key success factors or some subjects that will be interested in. These subjects, they cut across all the various applications. Now, as it stands now, assuming that the university wants to look at its revenue from these various applications, so the university will need to come and look at maybe a hospital management system that the university has to go and pull the revenue from there. Then we will come to hostel management, come and look at the revenue from there. Student fee payment, something, what do we call it? Student fee payments, user fees, facility user fees. We need to pull revenue from there. These are different applications, and we have to be pulling revenue. This revenue cuts across all of them. And therefore, when we come to data warehousing, we say that but there is a particular subject or critical success factor that cuts across all these various business processes. And therefore, why wouldn't we rather organize applications or decisions that we want to pull from various applications based on the subject, but not necessarily the business process? Okay, now business processes are already in place. So now we want to, somebody should tell me if we want to get revenues. These are different databases: hospital management, hostel management, students fee management system. And then we are looking for the revenue. This is a relational database. How do we obtain the total revenue from these various applications? Can somebody suggest what we need to do? Anybody?
I think we need to take the sum total of all the business processes and then add them together.
Okay, so that's what we normally do. So if it happens that hospital management software, then be the person responsible will, maybe the chancellor will ask, can you provide us with the total revenue for this month or something? Then we'll ask the student fee portal or something, the person responds, provide us with this figure. Then we add all of them that will help us make a certain decision. Maybe we want to build more facilities and we'll know our revenue and then go ahead and do that. But in actual fact, when you come to data warehousing, we are saying that, okay, fine. You have organized your operational systems based on application and business processes. How can we at the top level be able to take a decision based on critical success factors? One of them is revenue across all these applications. So that becomes a problem. The way we've been doing it now, having to go here, pull this from here, add this to that. No. Can we have an application that can pull this information for us across all the various applications? So here in data warehousing design, or when we are designing a system for data warehousing, we rather identify the subjects of interest, not the design of data warehousing. Our attention is on the subject. That's why we say subject oriented. Subject oriented. Subjects may differ from one organization to the other. The subjects are normally referred to as critical factors. The critical factors are factors that affect the performance of the organization. Critical factors are the ones, or they are the factors or the subjects that affect the performance of the organization. Every organization or every enterprise has something we use to measure its performance. So I'm going to take you back to, let's say, in educational environment regarding students progress or students database. What do you think will be some of the critical factors? The critical factors are subjects that we use to measure performance. So in academic environment concerning students' records, what subjects will you consider as critical factors?
I think, Prof,
School
the graduation
fees.
I
rate.
think as an output,
The graduation
results
rate.
can be considered.
Okay. Now, what is it on the graduation list that we can use to measure that, or we can consider as critical factor? What is on that graduation list?
The CP,
School
the
fees, your
CGPA.
grade.
GPA, maybe GPA. Then maybe grade, GPA. What else?
If you don't own school fees.
Yes, school fees payment is also a critical. Is a subject that is of interest. Which all these things will be used to judge performance, is that not it? Because we can say school fees. Have they paid? They haven't paid, then the performance is poor. Everybody has paid, then the performance is high. The subjects that we use to measure performance, GPA, then it can also be how many people are having maybe first class. So we use the classes also to measure performance. What other factors do we use to measure? Now I broaden it to a university. If we want to measure performance in the university, what are some of the other subjects that we will use to measure them?
Hello, Prof. Can we say output of research by the faculty?
Yes, research output. So it's also a, how do we call it, a critical factor. So I just want you to understand how to identify critical factors. And these critical factors, they are the things we call subjects. So when designing a data warehouse, and instead of telling you to identify the entity, identify the attribute and all this, I'm not going to say that one here. But the first thing I will tell you is to identify the subject. And the subjects will differ from one institution to the other. Assuming we are in the banking industry or banking sector, what are some of the things that you think will be the subjects you will need to look out for? Anybody?
Nothing.
Yes.
The credit worthiness of the customer.
That's right, credit worthiness. There are ways that even they calculate the credit worthiness of customers. So that's one. Another,
How many people are able to repay their loans?
exactly, that's another. Then loan defaults and loan payment rates and so forth. Okay, without wasting more time, it appears you have understood what it means when we say subject. Okay. In a manufacturing, sorry, in a manufacturing company's sales, even shipment, stock, inventory, all those things are subjects. Because the subjects, one thing about subjects, the subject oriented or subjects is that the subjects cut across various business processes. So if we mention profit, we can get profit from hospital management system. We can get profit from student fee payments portal. We can get profit from hostel management. And so you see that subjects cut across various business processes. So in data warehousing design, one of the very first things you should look out for is the subject. Okay, that's why we say it is subject oriented. So the next keyword we want to define is now integrated. So let's define integrated. Okay. When dealing with data warehousing, as I did mention from my initial introduction, I mentioned that the major problem with relational databases is that some kind of data that it can store will only be data that we can structure. But when you come to data warehousing, we want to incorporate every data, whether structured, semi-structured, or unstructured. That's why we say integrated. Integrate data from every source. So when we want to, let's say, develop, just as the example that I gave, we can take our operational data base, all right. Then we can pull some maybe critical information from some websites that contain some kind of data. We can pull the company's minutes. We can even take user manual, email contents, the WhatsApp contents. We'll pull all of them together now and dump them into a warehouse. And that is where we come by that name, data warehousing. So data comes from several applications. Of course, your relational databases are also part of it. So your hospital management, hostel management, fee payments, the financial data, all of them together with unstructured data. We pull all of them together and then we put them into the warehouse. Okay, so that is integrated. Data should come from various sources, external sources, other companies' data that might be relevant to you, and so forth. Immediately we say so, some of you ask problems, or may ask questions, or there might be some problems. Some of you be thinking, how can you take email messages and how are you going to store them into a database? It's going to be a problem. And of course, there are a lot of challenges to be overcome, but there are also tools to do the data cleaning for you. So problems having to do with integration may be file layout, encoding system, file names, various file system architectures, and I mean heterogeneity of the data and so forth. These are some challenges that comes with the integration that we are talking about. So for data warehousing, then we will have subject-oriented and integrated data from various sources, internal sources, external sources, structured data, unstructured data, semi-structured, and so forth. And for that matter, there is a component within the data warehousing schemas, some components or some programming models that help us to clean the data so that we can pull all these data into the same format before we store them into the data warehouse. So we'll be talking about those as we go along. We call them the process of extraction, transformation, and loading. We'll be discussing them as we go along. Okay, I may have to pause here for a moment. If you have question or seeking some clarification, I think I can do that before we continue. Okay. Since we don't have a question, it means so far so good. All right. So now the third keyword is time variant. Decision making is generally based on time. It's based on time. Sometimes we want to see what was the sales total as at a certain point in time. What has been the pattern of sales for the past 20 years? Or what has been, we want to see certain trend. But in general, we have some problem with what do we call operational systems. That operational systems happen to concentrate too much on what do you call it? Current values. Current values. For instance, if you ask that maybe we make a change to your name and we go and do that update, we may even end up overwriting the wrong previous name, and then it will now represent the current value. So the operational system has something we call update. So we keep updating and overwriting previous values and so forth. So in data warehousing, we are not only interested in current values, but we are also interested in what has been the various values. For instance, if we what do I call it? Let me probably bring this in here. The data warehousing schemas want a snapshot of the state of events at a time, and we need to take these snapshots at certain time intervals such that we can be able to say time 1 the total was this, time 2 the total changes to this, time 3, and even with that we can even generate time series analysis or do trend analysis, or we can generate some kind of decision from it if our data that we are interested in is peaked within certain time durations, that's time variant, rather than in a database management system when you go and see the current values. But what was the value in the morning, for instance? The banks try to keep current values and balances, but even there are a lot of problems. For instance, if we want to know what has been the balance as at the close of day yesterday, And then what has been the balance as at close of day to day. I'm sure from even banking this, we can see balances, so we would know. But if, for instance, we want to see the balances of the account as at every 1 hour, if the banks will not make conscious effort to be computing the balances as at each 1 hour, then they will need to have to go back to the transactions to recompute those balances, maybe hourly by hourly or minute by minute, because current values are the previous values have been overwritten by current values. But in data warehousing, it is not so. We want to be able to see the data at each time interval or each time domain. What has been the state of the data at each time domain. When we do that, it will allow us to do some analysis of the past, even relates the information to the present. Even we can be able to forecast the future, because each snapshot of the data at one time comes with time. It can be a day or minute or hour or weekend or weekly, and so forth and so forth. So that is one of the key issues about data warehousing, time variant. The last one, or the last but one, is non-volatile. In data warehousing, it will interest you to know that by way of concept, we don't update. And since you don't update, you don't overwrite. So data from operational data sources and other sources could be taken within certain time interval and dumped into the warehouse. Let's say we take a backup of all the data that we have, and then we come and dump it into a warehouse, including all the unstructured data. Then maybe we keep doing this every evening. Another evening, we take backup of all the records and unstructured data, all of them. We again take a snapshot of it. We go and dump it into a data warehouse. The following day, we take all the data again, we come and dump it into the data warehouse. So when we are dumping the non-volatile, means that don't go and dump it to override the one that you put there yesterday. Even though there will be a lot of redundancy in it, just dump it as it were. Don't do so-called normalization to remove some data so that you don't have repetitions or redundancy. No. Data warehousing, for data warehousing, is about repetition. It's about redundancy. So you will say that this concept deviates from relational databases where you need to remove redundancy. This one is saying that redundancy is fine, and that's what we want. Just take a snapshot of the state of the data at that time with the time attached to it, and then dump it or load it into a data warehouse within certain intervals that the company agrees on. Just be loading them into the data warehouse. So that is non-volatile. Don't remove or overwrite or delete records from the data warehouse. Rather dump new ones into it. One time I said this, and some students said, "Hey, but Prof, this one it will create problems, so the data will become so huge." Do you think that way, that it will grow so large that maybe space will become a problem?
Yes.
No, no, Prof.
It will become a
Well,
problem, isn't it?
no, it can never be a problem, because so far as we are saying that is a warehouse. Warehouse is something very large, can contain a lot of data.
Okay. So when the space is running out, what do you do?
No, usually when the space is running out,
You buy more.
We have
You buy
another.
more.
Yes.
You buy more space. So that means you increase the warehouse. It's like these agencies buying cocoa in Ghana. When you go to the cocoa producing regions, you see the warehouse. When the particular years where it happens that we get a lot of it. I stayed in the village, so I know what is done. The government puts up a lot of warehouses there. Sometimes they have to expand it, or they have to collect some and send them to another warehouse. So instead of throwing the cocoa seedlings away, that no, this one we don't need it again because the warehouse is full. You keep increasing the warehouse to accommodate it. So in data warehousing, we don't overwrite.
Prof, what if
Update.
it expired? It has expired.
The data warehousing, it's a good question. But interestingly, it doesn't even expire. Because the reason why you are
Yeah,
developing
data
data
that is archaic.
it won't expire. The reason why it will not expire is when you see the definition again, all these that you are doing, subject-oriented, integrated, non-volatile, time-variant collection of data, in favor of what? Decision making. So because of the decision making, the data that you put there 50 years ago will not expire because it will even help us to see the trend. That 50 years ago, what has been our sales? How have we improved upon the sales up to today? So we can even draw a graph. The actual data warehousing is all about decision making. That is the reason why we don't insert, so to speak. We don't insert means that you load the data, but we don't update, we don't delete. So if that 50 years ago data is still there, it's still very good for decision making because we can put a machine learning tool on it to read through to show us patterns or to generate histogram or time series analysis. Now, say 50 years ago, our company's capacity was something and our production was this. How have we been improving over time? Then the time series graph or some would draw and tell us, oh, we've been doing well, or at a certain time our production dropped, and so it cannot expire. Do you understand why it can expire? Because everything about data warehouse is our decision making.
Does it mean that in the definition? Hello, Prof.
Yes.
So meaning that. And in the data, it deals with the quality of the data for decision making, which is timeless.
We can't hear you well. Just start the yeah, go ahead. I think we lost you. So any other question from anybody?
Hello.
Any other question or concern from? Yes, Erasmus.
Yeah. Prof, I wanted to know in practice how this thing work in a company. What I mean is every staff have access to the warehouse, or it's only the top management who has access to the warehouse? If it's a top management has access to the warehouse, how are they getting information before they send it to the warehouse? Or I don't know. Can you please help us to understand the reality of the use of the warehouse? Thank you.
Okay. The IT persons, persons like you, we have the data warehousing databases. Oracle has it, DB2 has it, and many the relational database management systems are built into their relational databases warehousing schemes. So people like you, that's why I'm teaching you, will use the concept that we are learning from here, just as we learn the concept from relational databases, and I give you some assignment to do, create it and design it and put some data inside. It's the same thing. So here, to you use the concept that we are coming to learn. Then you go into Oracle, use the models that permit or the models that allow you to design a warehouse. So you will design it. So we will be coming to entities and all that very soon. But the concept is different. Then the designing paradigms are different. So you go through it, then you design it just as you design an application. After designing that application, then you generally would do all the needful privileges, logins, and then so on. So top management will open the application, and then in the development we have query languages that are embedded into your reports, and then but the idea here is that your system will be able to generate a lot of graphical interfaces, so that because top managers sometimes cannot interpret these figures and so forth, but they interpret it better when they see graphs and diagrams showing trends and all that. So you do all the development and then install the system. Then top managers can log in. Let's say he wants to see certain decisions and where will be appropriate place to site, maybe a factory. Then because all the data loading into the data warehouse, and maybe a system administrator can be doing that at the background, or with a click of a button, be loading the data from various sources, clean the data, and be sending into the data warehouse. The CEO who knows nothing about how the data is being loaded will go into the application at the top and then be able to click on icons and beautiful screens to be seeing his reports and diagrams and figures and trend reports, histograms, pie chart, and then all sorts of things to be using the system from the top. So it is a system on its own that will be developed by you. And that's why I'm teaching you, so that you know how to do it. Can you see the picture now? Erasmus, can you see the picture?
Yes, Prof.
Okay. Any other question from anybody?
Yes, Prof. It's very, very clear now. Thank you very much.
That's right. That's right. Any other person? This is a concept that is very important. So all that data warehousing is about decision making. It doesn't store data by itself, but it picks data from all various applications and then send it to the warehouse. Then we put analytical processing engine on top of the data warehouse to be able to fetch patterns and trends from the data that we stored in the warehouse. That would help management decision making. Okay, having said so, if you don't have any other question, we are done with the definition. The definition is very, very, very important. All those keywords are critically important to the understanding of the lecture that follows. When you move on, you'll be seeing or subject-oriented, integrated, all the design that you will see is the same concept that we will use throughout. Okay, having said so, We will take a short break of 5 minutes. When we return, we will continue. We'll look at the architecture. And then, if time permits us, we'll start looking at the dimensional modeling. So we'll come back 10 minutes past 8. We'll come back to continue. Okay, so we want to continue from here. I'm sure you can still hear me loud and clear. Are you with me?
Yes, please. We are.
Okay. Now we want to look at the architecture. So let me just show you the architecture. Okay, look carefully on this. And then you can see the architecture. We have various components. We have information sources. Then we have the data warehouse server, which is tier 1. Online analytical processing engine server, which is tier 2. Then we have the client, tier 3. So for each of the tiers, you can see. Take a moment and look on this carefully. Okay. Having observed it carefully, when you take a closer look at the information sources, as we said earlier, that in data warehousing schemes, data can be extracted from various sources, including semi-structured, unstructured, and operational databases. So these combinations of sources of data will be extracted using a model, a programming model. We call it ETS. ETS. This data extracted from various sources will be put into an area we refer to as staging area. During this staging area, data formats may differ from data from various sources. Even file structures. So this extract, transform, loading model will do the data cleaning. And then, so to speak, normalize the data into the same format for all sources of data, including the attributes and so forth, data types, and all that will be taken care of from ETL2, which is the software component. Now, when that is done, the data is then loaded into the data warehouse. The data warehouse, as it is so big, can be segmented into smaller databases to take care of various data, various databases. So we have what we call data mats. Data mats, we'll be talking about them as we go along, but they are segments of various databases that can be pulled together to give you the full data warehouse. Now, so you will see that the data warehouse, so to speak, is a database on its own that stores the data extracted from various sources into the data warehouse. Now, having said so, but that's not all. You just put into the data warehouse. What do we do with it? There must be some online analytical processing tool that should read the data, machine learning algorithms that should read this data stored in the data warehouse. And that is where we have the tier 2, which can be series of servers, not even one. That's why we say online analytical processing servers. That will now take its input or feed from the data in the data warehouse, process it, the data, and then provide output or reports. That's where we have the tier 3, the clients will now be able to fetch data, the analysis or queries or reports or data mining, all from through the analytical data processing tools. So over here, where we have the OLAP servers, is where the engine is. We have various servers. We have MOLAP, we have ROLAP, and many other names that we'll be discussing later on. Okay, so this is the, so to speak, the architecture. Is there any comment or question on the architecture? In fact, from now going, okay, you can ask your question before we continue.
Prof, looking at the architecture, we have data mat, and it's like the data mat also absorb some of the data from the data warehouse.
Now, what I said is this is a very big data warehouse, but data warehouse can be segregated into smaller data warehouses. So if we have a big data warehouse and then you divide them into smaller data warehouses, we call them data mats. They are meant to somehow keep track of a particular data warehouse. For instance, if you even build physical data warehouse and we can segregate them into segments or sections. Maybe one section you want to keep certain kind of data there. Another segment, maybe a different types of words there and so forth. So there's a big data warehouse that we segregate into smaller data warehouses and we call them data mats. So we can choose to create data mats for maybe some related items so that we will know that on this data mat we have this kind of data in there. So that is how come we have data mats.
Okay, thank you.
Any other question? Feel free to ask questions, make comments.
Hello,
Isaac.
Prof.
Okay, Gifty, go ahead.
Okay, so Prof, I wanted to know, are there any rules bounding the maybe storing of any type of data inside the data warehouse? Maybe this is relational database. This one is non-relational. Are there rules inside the data warehouse bounding some things?
Yes, you see where we have the information sources. There is a ETL tool, which is a programming built into the data. Let's say built into Oracle, because Oracle has a data warehouse and component. Some are built into the data warehouse database itself. So it is here that the rules you are talking about become important. The rules become important here because if you are unable to pull these various sort of data and put them into the same format, you can load them into the data warehouse because they must all now follow the same rules like we were saying. How we are learning entities relationship, this must relate to something, other must be related to. All those things are taken care of here. during the data cleaning and data formatting and so forth. So it will interest you to know that even your email data together with your operational data will all be merged into a form that the data warehouse can save. In fact, when you go in, very soon you will see that the data warehousing structures are just like the same as the similar to that of relational databases with entities, attributes, and all that is the same. But here, the rules will apply. That what kind of data, how should it format the data in what format? If you don't follow the format, you can't load it into the data warehouse because they are not in the same format. So the rules are actually here. Just as we have a lot of rules that if you have primary key, when you have secondary key, there must be the primary key in another table. Similar things are also here that we'll be talking about. So there are rules, but most of the rules start from here. If you get the data loading side wrong, then analytical tools and all those things cannot get the needed information. So the difficult part of data warehousing is the information sources where you need to do the extract, transform, and load data cleaning and all that. That's where there are rules over here. We'll be seeing some of the rules as we go along.
Okay, thank you, sir.
Okay. Okay. Any other person? Okay. Now we can move on from here to look at. From here onwards, we begin to pick each of these components to discuss them so that we will understand better the architecture. So when you look at this very well, it has various components. The components are broken down into the following: source data component, data staging component, information delivery component, metadata component, management and control components. This is similar to that of relational database when we were discussing that we have various components and we're talking about all those. This also has its own components. So as you can see, this is source data component. This is the source data component. Then we have the data staging component. Data staging component is where we do the extraction and all that. Then information delivery component is the client tier 3. Tier 3 where the users will have access to the data. Then we have metadata component, which is embedded into the data warehousing itself. The catalog taking care of the data, describing the data. In data warehousing, metadata is critically important, but we may not have enough time to go deep into metadata and others since we are coming to end on the design. So the metadata is also built into this component tier 1 over here. Then of course, in every application, you should have a system whereby you can manage the whole database. So management and control having to do with things regarding privileges, security, all those other utilities and all that, how to manage the database, maybe interfaces to create the data warehouse and data mart, and all that are also embedded into the architecture as we see over here. So having said so, most of the things I'm coming to talk about, we've mentioned them, like data source component. The data source component includes production data, internal data, even archive data that has even already been archived. Then external data. And that forms this segment: structured, semi-structured, unstructured. So production data is data coming from operational systems. That's the, what do we call it, the databases that the organization is already using. Operational databases like the ones we mentioned earlier. Hospital management, hotel management, all those are operational database. Or some segments selected from the operational databases. Then we have external data. External data can be even worksheets, documents, customer profiles, and so forth. Because most of this external data may even be text documents, maybe Word file, Excel sheets, and then so forth. And of course, when they are in this format, some amount of cleaning and reformatting will become important. Then archive data may be old data that has been archived. We can take snapshot of historic data. And then external data can be data from some websites and then so forth. Maybe we need to be looking at stock changes, stock prices, and so forth. So we'll go to Ghana Stock Exchange website or Bank of Ghana website to see maybe some trends in exchange rates, official exchange rates. So we can pull data from some other external sources into our data warehouse, and that will help us or will help our analytical engines to be able to draw some or maybe give us certain reports together with our internal data. Okay, so that was a data warehouse, data source or source data components. I don't think we have questions here, but if you have, you can ask me. Okay.
Prof,
the next, yes.
Please add this architecture, the data warehouse architecture. I'm a bit confused with the data staging. Is it part of the source data component or is part of the data warehouse? Because it seems to be in the middle.
Actually, when you look at the diagram, very well, they are looked at as though they are source data, but critically speaking, the source data is being extracted. The source data in itself is being extracted using these tools, ETL tools. So when you have, let's say, your Excel sheet, your Word document, email file, WhatsApp document, project document, minutes of meetings, and so forth, they themselves cannot be loaded into the staging area for further processing. So you open this application, which is an ETL tool, software application. Then you go select these files, these sources of files. Then it will help you extract the data from the sources and then put it into a temporary place we call staging area. At this staging area, the transform, the extract will extract it first.
Well, please, which application do you use to extract the?
Some applications are built into the software that you are using. Some are even in Oracle.
Okay.
Some are also developed by programmers and they can buy from the market. Sometimes even programmers even write them themselves to do the extraction.
Okay. Thank you.
So this, there you understand. So it's a software component that you can use to extract. Then the same software company can transform, because the data are from different sources, their structures, data types may differ. After transforming them and do the cleaning, the same software in the middle here can load. The loading means that you are now copying it into the data warehouse. then you load it into the data warehouse. But when it is extracted, they are first kept in a staging area for cleaning. After all the cleaning is done, then you can then load. You do understand what we are talking about now?
Yes, so in if I get everything, then it means the ETLs are not themselves part of the extraction. They just process the information that has been extracted and then put it in the warehouse.
Yes, that's why you see here, when we are looking at major components, we separate the source data component from data staging component. The data staging component is where the ETL, all those counts to do the cleaning and all that before you load. The source data is only telling us that you can get the data from Excel sheets. You can get the data from so and so and so and so. But how would that data be loaded, be taken? A software to help you pull it into staging area. Staging area will process it further to clean it, and then load it into the data warehouse.
Yes, Prof. But also at this particular point, the major component, it looks like we skip the warehouse component, or that's not part.
In fact, the warehouse component is a major part of it. But I think what is being represented there is the metadata, because the metadata is actually on the database itself. You saw the metadata component.
Yes, Prof.
The metadata component is actually residing. In actual fact, data warehousing schemas what they depend on is the metadata. But
Okay.
I understand where you are coming from. A lot of work actually goes on also at the data warehouse, because this is where you create the data warehouse, you create the entities, their relationships, and then so forth and so forth. This is where you do all that, the data warehouse. And then you also work with the metadata and then so forth. They are all happening here. Okay. So now, okay. Okay, so now we can look at the data staging component. We've talked a lot about it already. After data is extracted, which is done by the ETL, the E side of the ETL, the data has to be prepared. The preparation may take the form of changing the structures, converting even date formats, and putting in a format that is ready. And these are the structures that extract, transform, and load. We normally call it ETL. When it is done, the data, the transform side of it will perform the cleaning, changing, even combining some data or converting some data from one data type to another. For instance, if you extract data from various databases, even the date formats will differ. So the transform portion of the programming model here will do maybe date formatting, so that all of them will take the same date formatting. Maybe some columns need to be removed, others need to be combined, and so forth. So all that will be done under the data staging stage of the data warehousing processes. Okay. Then the data storage component, I think that's the one that you were talking about that is removed from the list. Let's put it there so that you don't have that problem. data storage component. So this is a data storage component where we actually have the data warehouse with the metadata. So one can imagine what goes in there. You can create various or separate repositories that we normally refer to as data mats. You will need to structure the data for efficient processing. We'll be dealing with that in our next class. We'll be looking at how the design should be such that we can have a good structure for efficient queries, because we also have queries just as we have SQL statements. And for me, the data warehousing queries are easier to deal with even than the relational database queries that we've been working with, because data warehousing schemas do not deal with too many tables and then child table, parent table, and make things so complex. So when we come there, we will see how we will structure the data for efficient data processing. Within the data storage component, as I told you, we allow redundancy. So when we are looking at the design, you will see how we introduce redundancy. And I also mentioned that update or loading into the data warehousing database is done within specific time duration. That's a time variant that we talk about. So a particular institution may choose, depending on the particular application in question, that they will be loading data into their data warehousing every day. Some can do it weekly, others monthly, and then so forth and so forth. Okay, so maybe the kind of reports that we want to be generating from the data warehouse would indicate what frequencies data should be loaded into the data warehousing schemes. Now, let me ask you a question. Assuming in the academic environment, we develop a data warehousing scheme, and then we want the vice chancellor, the boards, the deans, and all those at the higher positions to be able to be viewing certain reports about academic performances of students and other related reports, maybe even compared with other universities in the country or across the globe, and we develop a data warehousing schemes for them to do that. How often do you think that the data warehouse need to be updated, or we need to be loading data into it? Should it be daily or hourly, daily, weekly, bi-weekly, monthly, quarterly, or half yearly, or annually, or every 5 years? How often do you think we will need to be updating or loading data into the data warehouse? Anybody can. Okay, Isaac.
Prof, maybe we can say since it's a semester run institution, we could do it biannually or half annually. I don't the term.
Yeah, half yearly. Every year once. Okay. Any other person, Erasmus?
Hello, Prof.
Erasmus.
I think it depends on the institutional need.
Assuming that
Yeah.
assuming is a University of Ghana. Assuming it's University of Ghana, how often do you think?
I think twice a year will be okay, or sometimes quarterly.
Okay.
Depending on the nature of this data too. For instance, if it's a financial listing, then it may go in for quarterly. But if it's a student record, then semester based.
Okay.
So
Any other person's view?
Mike was misbehaving.
Is there any other person's view?
Yes, Prof. So I think if maybe they just want to look at student attendance, it could be daily, and then maybe they could see whatever they want to forecast. Maybe what are causing students not to attend class. If it's really about that, it could be daily for them to monitor it.
Okay, all right, okay. Yo, all the answers are right, depending on what you want to use it for. So if you want to monitor attendance, then maybe we should be loading it daily. Then we can be able to be viewing because the student numbers are large. And if you want to be seeing classes, various classes and the attendance and how the attendance records has been, whether it's going down or it's coming up and so on, then Gifty, I agree with you that if that kind of data is part of this daily would do. If it is student records, I think maybe the University of Ghana, I think maybe every 2 months will be better than half yearly because we have various categories of students. Because people are completing school at various times, even though we accumulate them and then we treat them all as a whole. Decision making will be based more on what has been happening over time rather than to wait for 6 months to be judging certain issues. But depending on how somebody said it, the kind of information they are looking for, the frequency may differ. As Gifty rightly puts it, if the attendance will be daily. Maybe if there's something else, maybe students' fee payment, maybe it could also be daily. And then so forth. Okay, having said so, let's continue. We talk about the fact that at the data storage area, the data loaded will be read only. You remember that read only. That is the key word for read only is non-volatile. That means don't go and override the previous data. That's why here we put it simply read only. Read only. But as we go along, even though the concept says it should be read only, assuming you wrongly upload the data, that's not the file you wanted to upload, and you wrongly upload a data, it does not mean that you cannot take it off. There is a facility you can, within the software, where you can delete, you can actually take it off. That doesn't defeat the concept of read only. That might be a mistake you made. You want to remove it and load the right data. But we don't overwrite. What you sent previously should not go and overwrite. Even with that same concept, in the software, there is a checkbox or a facility where you can say that, oh, no, this one I loaded yesterday, I really want to overwrite it. You can overwrite it. But by concept and by design, you should not overwrite until it becomes, you see it as something you really need to take away or overwrite. You can overwrite. Okay. Having said so, the next stage is information delivery component, where we have issues with authentication, privileges, logins, and then monitoring of the whole system, utilities to see the performance of the system, and then storage engines, users' performance, and then so on and so on are part of the information delivery component. Okay. Here we do not discuss the metadata, but we'll be coming across it, and I will talk about the metadata. Okay. Having said so, we want to delve into we've seen the architecture, and now I want to delve into the design. That's where the work is. The design is where the work is. Just as we were looking at entity relationship, database management design, and we use largely the entity relationship. Here also we have data warehouse design. But over here, we don't use the entity relationship anymore. It comes with its own design. And the name of that design is dimensional modeling. Dimensional modeling. So instead of saying entity relationship model, data warehouse, and you have dimensional modeling. So we can talk a bit about reminding ourselves concerning the entity relationship. The entity relationship concept tells us that as much as possible, you should reduce redundancy from the database. That's why we come to normalization and then child parent table and all sort of issues. And in entity relationship, also we have all these 4 key things that we do. We can insert, we can update, we can delete, I think we can select. So we do all these 4 things. But when you come to data warehousing, it is only one of them that is important to us. Which one? Who can guess the one that is important to us out of the 4 things I just mentioned? Delete, update, select, and also insert. In data warehouse, which one is the more important to us?
I think
Anybody?
insert will be preferred.
Insert.
Okay. You've tried, but that's not the most important. The most important is
The select.
select. Because data warehousing is all about reports. The data that you dump there, you are right to say insert because the data that you put there is actually insert. So you insert it into the data warehousing table. So you are right. But I'm looking out for these are the 2 things we actually do there, the insert and then but the insert is not done by users on the terminal, it's done through uploading. After you work on the data staging and you upload, so to speak, or you load. So that is what we can look at as insert. The data loaded into tables, but not individuals, posting transactions into the table. The most important one is select. So when we come to data warehousing schemas, we don't actually have update and delete because you remember the concept of non-volatile, don't overwrite. In entity relationship models, we have large number of tables. So far as we are splitting tables through normalization, the table numbers are becoming a lot. And for each of you, if you have used databases before, when the tables become many, even retrieving records from them takes a lot of time. So it borders on performance. The performance tends to degrade when the tables are many. So you can now understand why data warehousing schemes should not follow entity relationship design. Otherwise, because we are dealing with large data or large amount of data is now coming to be accumulated into these tables, and queries to retrieve from multiple tables are going to take lifetime. And therefore, the design must change such that we can query quickly large data and then be able to find results. Okay, having said so, uh, we will delve into the dimensional modeling when we meet next time. So for the next few minutes that we have, you can ask me any question that is going through your mind, or maybe seek clarification to something. We have about 5 minutes or so to go. And we can reserve the design to next week. Are we coming to meet next week? When is our lectures, the school going on? What do we call it? A break. When is the break starting?
I think Friday.
Okay, and we will return when? Okay, we can cross-check that information, but school goes on break on Friday, so it's likely I will meet the weekend, Saturday, but it's likely we will not meet next Tuesday, because next Tuesday would even be Christmas Eve or something, I suppose. Okay, so if anybody has a question, comment.
Yes, Prof, I have a question.
Okay.
But say it's about the other lecture. Since we didn't meet on Saturday, I wanted to ask about the round robin partitioning. Can I go back and ask that question?
But you are a weekend school. You are part of weekend cohort. Is that not it?
Yes, sir.
So I'll be teaching it next week, Saturday weekend, because weekend students will not join the class the other day. Only one or two of you.
Okay.
So
I should
maybe
hold
you
on with
can
my
still
question.
hold on with the question. When we meet Saturday, you can ask it, because I need to teach the same day. I can't deprive them of that.
Okay. Yes, sir.
Okay. Any other question or general concern? Any other general concern that may not relate directly to what I've taught today? Okay.
Good evening, Prof. Please, Saturday will be in person or online?
Saturday. I don't know, which one do you prefer? Other
Online.
lecturers coming there to teach.
Please, no. Only you and
No.
the research man.
So then we can do it on. We can do it online.
Okay,
Yes, we prefer that one. Thank you.
We can do it online. When we return in January, we can have one or two. I think when we return, we have about 2 or 3 classes to go or so. At least
Prof,
yes.
I wanted to know whether the university has a data warehouse.
So far, I don't think. Even if they are implemented, I don't know. But so far, I don't think. Only few companies that I know had this data warehousing scheme. Bank of Ghana was implementing it as the past 2 years that I know. VRA2 was making some attempt to implement it, but I don't know how effectively they are working. So it's not very common in many organizations. Many organizations are making attempts but I don't know how well they are working. But
And
if
then,
anybody knows of any organization using it, maybe can let us know. But I believe some of the banks should be having some of these things. If not, I don't know. If you know of any.
And the storage, are they using servers or they are using clouds for storage purposes?
It will interest you to know that so far as I know, but things keep changing over time. So far as I know, Bank of Ghana has its own data center, and many other organizations have their own data center.
Okay.
So they use their own servers from their data center.
Oh, okay.
But you can also use a cloud storage for it. For smaller organizations, that would be more cost effective than to have to set up your own data center. That could be very expensive.
Thank you, Prof.
Erasmus, your hand is up.
Yes, I just checked the calendar. The Christmas break is from 24th December to 7th January.
24th.
So this was the Tuesday, 24th December to Tuesday, 7th January. So teaching.
So does it mean that next week, Tuesday 24, we should be having a class?
Normally,
which calendar are you using?
For students is from 21st to 6th
21st.
January.
That's the communication they sent. 21st.
It's 21st. It's on the calendar. Check on the university calendar. Is there?
Yes, 21st.
Yeah,
21st.
Saturday.
Okay, yeah, Saturday. Okay, that means I can meet the Saturday group on Saturday, but the Tuesday I do not know who may want to ask students to come to class on 24th. Some of you are traveling and even the lecturer.
The 24th is for staff. The staff is breaking on 24th.
Exactly.
In the afternoon. Yeah.
Exactly. All right. So I wish you all well. Take good care during the Christmas break. Those of you who attend church like me, please avail yourself in church activities and enjoy yourself. But make sure that you don't fall victim of any hooligan activities. And those of you who drink, please take good care. Don't go and drink too much.
Thank you, Prof.
Take good care.
We wish you Merry Christmas in advance.
All the best. All the best. All the best. Okay, so bye-bye. We'll meet again.
Bye-bye.
God willing.
Bye.
Bye. Bye.
Bye.